Hey everyone, before we dive into the story, make sure to hit that subscribe button and give this video a like. Trust me, by the time we're done, you're going to want to be part of this channel. In 2022, an 87-year-old man was hooked up to a brain scanner when his heart stopped. Nobody expected what happened next. In the 30 seconds before and after he died, his brain did not go dark. It erupted. Gamma waves, the fastest brain oscillations we know of, the same patterns associated with dreaming, memory, and deep meditation, surged through his cortex. The dying brain was not shutting down. It was lighting up, and what it appeared to be doing was replaying a life. Tonight, we are going to follow that discovery into the deepest question any human being will ever face. What happens after we die? The answer involves a molecule your brain may be manufacturing right now. A phenomenon that makes Alzheimer patients wake up and speak for the first time in years. Ancient maps of the afterlife that match modern neuroscience with terrifying precision. And a Nobel Prize-winning physicist who believes consciousness may be woven into the fabric of the universe itself. This is going to change the way you think about death. This is going to change the way you think about everything. In 2022, doctors in Estonia were monitoring an 87-year-old man for seizures. He was hooked up to an electroencephalogram, a machine that tracks brain waves in real time. They were not studying death. They were studying epilepsy. But then his heart stopped. And because the machine was still running, they captured something that had never been recorded before. The final 30 seconds of a human brain. What they saw was not silence. It was not a slow fade into darkness. The dying brain erupted. Gamma waves, the fastest brain oscillations we know of, the same patterns associated with dreaming, with memory, with deep meditation, surged through his cortex in the moments before and after his heart gave out. The brain was not shutting down. It was lighting up. And what it appeared to be doing, according to the researchers who published the findings in Frontiers in Aging Neuroscience, was replaying a life. Dr. Ejmil Zemmer, a neurosurgeon at the University of Louisville, was one of the researchers who analyzed the data. They found that in the 30 seconds before and after the heart stopped beating, the brain showed a dramatic increase in gamma wave oscillations. Gamma waves are the highest frequency brain waves we can measure. They are associated with conscious perception, with active thinking, with the formation and retrieval of memories. They are the brain waves that fire when you are intensely focused, when you are meditating deeply, when you are dreaming vividly. Zemmer put it carefully. The brain may be playing a last recall of important life events just before we die. The same patterns that light up when you remember your childhood, when you dream about someone you love, when you concentrate on something that matters. Those patterns erupted in this man's dying brain. Not randomly, but in organized, coherent waves, as if the brain in its final moments was doing something deliberate. But this was one patient, one recording, one accidental glimpse. The scientific community needed more. And in 2023, they got it. Dr. Jima Borjajan, a neuroscientist at the University of Michigan, had been studying this question since 2013, when her lab discovered surges of gamma activity in the brains of dying rats. Now she turned her attention to humans. Her team monitored 4 patients in cardiac arrest using continuous EEG. These were comatose patients with no chance of recovery. Their families had agreed to remove life support. The EEG caps were placed before the ventilators were turned off. 2 of the 4 patients showed massive gamma wave surges in the moments after their ventilators were removed. The activity was concentrated in a specific region of the brain, the temporoparietal occipital junction. This area sits at the back of the brain behind the ear where the temporal lobe, the parietal lobe, and the occipital lobe converge. It is one of the most important regions in the neuroscience of consciousness. It is where the brain integrates sensory information into a unified experience. It is the region that activates during out-of-body experiences. It activates during vivid dreams. And it lit up like a storm in these dying brains. The gamma connectivity was not just local. It spread across hemispheres, linking the back of the brain to the prefrontal cortex at the front, the region responsible for higher-order thinking, decision-making, and self-awareness. The dying brain was not just firing randomly. It was communicating with itself. Regions that handle perception were talking to regions that handle meaning. Dr. George Maschauer, the founding director of the Michigan Center for Consciousness Science and a co-author of the study, described it as a neuroscientific paradox. How can vivid experience emerge from a brain that is shutting down? The mainstream assumption for decades had been that the brain simply gives up at the moment of death. Borgegin's data showed the opposite. But here is the detail that makes this truly unsettling. The gamma surges continued after the heart had stopped. The heart was no longer pumping blood. Oxygen was no longer reaching the brain. And yet the brain was more electrically active than it had been in the minutes before death. As if the loss of oxygen itself was the trigger. As if the brain, sensing the end, responded not with silence but with a final, desperate symphony of activity. There is a three-stage model emerging from this research. Dr. Charlotte Marshall at the University of Liège has described the neurological cascade of dying as a sequence. First, the surge, a heightened burst of activity as the brain responds to oxygen deprivation. This may be an instinctual survival attempt, a last effort by the brain to stay alive. Second, a slow wave, a period of lower frequency brain wave activity. Third, the flat line. EEG goes silent. But the flat line on the heart monitor, the one you see in hospital dramas, that is not brain death. Real brain death may occur minutes later, possibly longer. Dr. Sam Parnia, one of the world's leading researchers on death and resuscitation at NYU Langone Health, has argued that the process of dying is reversible for far longer than we ever assumed. His research suggests that meaningful brain activity may persist up to an hour after the heart stops, possibly even longer. Think about what that means. The moment we pronounce someone gone, their brain may still be active, still processing, still in some sense experiencing something. We cannot ask this 87-year-old man what he saw. We cannot ask those 4 patients in Michigan what they experienced. They are gone. The data is all we have. But the data is extraordinary. It tells us that the dying brain does not go gently. It fights. It surges. It activates the very regions associated with consciousness, with memory, with the experience of being alive. And it does this at the exact moment when, according to everything we thought we knew, it should be doing nothing at all. If the brain is this active during death, then what is it experiencing? Is it replaying a life? Is it generating one final dream? Is it opening a door that we, the living, cannot see? Some people have come back from the other side of that door. And what they describe is remarkably consistent across cultures, across continents, across centuries. In 2014, a study was published in the journal Resuscitation that represented the largest scientific investigation of death ever conducted. It was called the AWARE study, which stands for Awareness During Resuscitation. It was led by Dr. Sam Parnia, then at Stony Brook University, and it spanned 15 hospitals across the United Kingdom, the United States, and Austria. Over 4 years, the research team tracked 2,060 patients who suffered cardiac arrest. Their hearts stopped. They were clinically gone. And then some of them came back. Of the survivors who could be interviewed, 39% described a perception of awareness during the period when they were clinically dead. Not vague sensations, not confused fragments, but structured, meaningful experiences that many described as more real than waking life. One patient in particular caught the attention of the research team. He was a 57-year-old man who had suffered cardiac arrest in a hospital in the United Kingdom. His heart stopped for 3 minutes. During those 3 minutes, he had no heartbeat. No blood was circulating. According to standard neuroscience, his brain should have ceased functioning within 20 to 30 seconds of the heart stopping. And yet, when he was resuscitated, he described the events that had taken place in the room during those 3 minutes. He described the actions of the medical staff. He described the sounds of the machines. He described specific details that were later verified by the nurses and doctors who had been working on him. This is paradoxical. The brain typically ceases functioning within 20 to 30 seconds of the heart stopping. The man was accurate about events that occurred over a 3-minute window of clinical death. Either the brain was somehow still processing information without blood flow, or something else was going on. The AWARE team did not claim to know which. They simply reported the data. Then came AWARE 2, published in 2023 in the same journal. This follow-up study was even more ambitious. 25 hospitals, 567 cardiac arrest patients. And for the first time, 85 of those patients were monitored with continuous EEG during cardiopulmonary resuscitation. The researchers were not just interviewing survivors after the fact. They were watching the brain in real time as doctors fought to bring it back. Of the 53 patients who survived long enough to be discharged, 28 were interviewed. 11 of them, nearly 40%, reported memories or perceptions suggestive of consciousness during their cardiac arrest. 6 described vivid, structured experiences during periods of clinical death. Not hallucinations, not the confused jumble of a malfunctioning brain, but organized, sequential, meaningful experiences. And the EEG data added a layer that no previous study had captured. Brain wave patterns, including delta, theta, and alpha waves, types of electrical activity associated with various states of consciousness, were detected up to 60 minutes after clinical death had been declared. The brain was showing signs of organized electrical activity long into the CPR process. Parnia was direct about the implications. He said, "These lucid experiences cannot be considered a trick of a disordered or dying brain, but rather a unique human experience that emerges on the brink of death." His team hypothesized that the dying brain undergoes a process called disinhibition. Under normal circumstances, the brain has natural braking systems, inhibitory networks that filter and constrain conscious experience. When the brain begins to die, those braking systems fail. The filters come off. And what emerges, Parnia suggested, may include access to stored memories spanning from early childhood to the moment of death, evaluated not just as personal memories, but from the perspective of morality. That last detail is worth pausing on. Multiple survivors across both AWARE studies described not just remembering their lives but reliving them. And not just reliving them from their own perspective. They described experiencing the emotional impact of their actions on other people, feeling what others felt, seeing their own lives through the eyes of everyone they had affected. This is one of the most consistently reported features of the near-death experience across all research, not just the AWARE studies. It is called the Panoramic Life Review, and it appears in testimonies from around the world. The near-death experience has been studied for decades, long before Parnia's work, and across thousands of accounts from cardiac arrest survivors, from drowning victims, from people who came within moments of death from illness or injury, a set of remarkably consistent themes emerges. Separation from the body. Survivors describe floating above themselves, looking down at their own body and at the medical team working on them. Many describe a sense of calm detachment, watching the scene below without pain or fear, a tunnel or passage of light. Many describe moving through a dark space toward an overwhelming brightness. The light is not described as blinding or harsh, but as warm, welcoming, and profoundly loving. Encounters with others. Survivors frequently describe meeting deceased relatives, friends, or figures they interpret as spiritual beings. These encounters are described as deeply real, not dreamlike. The Life Review. A panoramic replay of the person's entire life, experienced not sequentially, but simultaneously with full emotional weight. Many describe feeling the impact of their kindness and their cruelty on others. A boundary, a border, a line, a river, a gate beyond which there is no return. Survivors describe reaching this point and being told or sensing that they must go back, that it is not their time, and an overwhelming sense of peace. Almost universally, survivors describe a feeling of love and acceptance so profound that many resist returning to their bodies. Many say it was the most real experience of their lives. The skeptical explanation is straightforward. The brain is dying. It is starved of oxygen. It is flooding with neurochemicals. And in its final distress, it generates a hallucination, a vivid, comforting hallucination designed by evolution to ease the process of death. The tunnel of light is simply the visual cortex misfiring as blood flow drops. The sense of peace is a surge of endorphins. The Life Review is random memory activation. The encounters with the dead are wish fulfillment. This explanation is plausible. Parts of it are almost certainly correct. The dying brain is a neurochemical storm, and some of what people experience during near-death is likely the product of that storm. But the skeptical explanation has a problem. Cannot easily account for the verified perceptions. The 57-year-old man in AWARE I who accurately described 3 minutes of events during cardiac arrest. The patients across multiple studies who reported specific details. The position of medical instruments, the words spoken by staff, the actions taken during resuscitation. Details that were later confirmed by the people in the room. If these experiences were purely internal hallucinations generated by a dying brain, how did the brain acquire accurate information about external events that occurred while it was flatlined? Parnia's team was cautious. They wrote that research to date has neither proved nor disproved the reality or meaning of patients' experiences and claims of awareness in relation to death. They did not claim that near-death experiences prove the existence of an afterlife. They did not claim that consciousness survives bodily death. They simply said the data is real, the experiences are real, and the conventional explanations do not fully account for what is being observed. But there is one substance that might bridge the gap between neuroscience and the visions that dying people describe. A molecule so powerful that a single dose can dissolve your sense of self entirely. A molecule that produces experiences almost identical to what near-death survivors report. A molecule that, according to a landmark 2019 study, your brain is already making. It is called dimethyltryptamine, DMT, and it may be the key to understanding what happens in the final moments of life. In 1990, a clinical psychiatrist named Rick Strassman at the University of New Mexico received something that no researcher in the United States had been granted in over 20 years: federal approval to give a powerful psychedelic drug to human volunteers. The drug was dimethyltryptamine, DMT, and what his subjects reported over the next 5 years would reshape the conversation about consciousness, death, and the boundary between science and the sacred. DMT is not a new discovery. Indigenous peoples of the Amazon basin have used it for centuries in the form of ayahuasca, a brewed drink made from plants containing DMT combined with a monoamine oxidase inhibitor that allows the molecule to survive digestion and reach the brain. In its pure form, when injected intravenously, DMT acts within seconds. The experience lasts roughly 15 to 20 minutes. And within those minutes, volunteers in Strassman's studies described things that sounded less like a drug trip and more like a journey to another dimension. They described the complete dissolution of their sense of self. They described moving through tunnels of light at impossible speed. They described encountering beings, entities, presences that felt more real than the waking world. They described overwhelming feelings of love, of knowledge, of unity with something vast and incomprehensible. Some described being shown their entire lives. Some described being told that death was not the end. Some described landscapes of impossible beauty. And when the drug wore off, many of them wept, not from fear, but from grief at having to come back. Strassman published his findings in 2000 in a book called DMT, The Spirit Molecule. In it, he proposed a radical hypothesis. He suggested that the pineal gland, a tiny structure deep in the center of the brain that the philosopher René Descartes once called the seat of the soul, might produce and release DMT at 3 critical moments: at birth, during dreaming, and at the moment of death. He proposed that DMT was not just a recreational drug. It was a biological mechanism for spiritual experience, a chemical bridge between the physical brain and whatever lies beyond it. The idea captured the imagination of millions. It also drew heavy criticism from the scientific community. The pineal gland is small, roughly the size of a grain of rice, weighing less than 0.2 of a gram. Its primary known function is producing melatonin, a hormone that regulates the sleep cycle. The idea that this tiny organ could produce enough DMT to generate a full psychedelic experience at the moment of death seemed to many scientists far-fetched. And then, in 2019, a study changed the landscape. A team led by John Dean at the University of Michigan, working under Dr. Jima Borjajan, the same neuroscientist who would later publish the Dying Brain Gamma Wave study, conducted a landmark investigation. Their results were published in Scientific Reports, a journal within the Nature portfolio, and what they found was stunning. First, they discovered that the gene for indolethylamine N-methyltransferase, known as INMT, the key enzyme required to synthesize DMT, is expressed not just in the pineal gland but across multiple regions of the brain. They found it in the cerebral cortex of both rats and humans. They found it in the choroid plexus, a structure that produces cerebrospinal fluid. And critically, they found that INMT was co-expressed with another enzyme called aromatic L-amino acid decarboxylase, or AADC, in the same brain cells. Both enzymes are needed to produce DMT, and they were sitting side by side in neurons of the mammalian neocortex. Second, they measured the actual concentrations of DMT in the brains of living rats using microdialysis, a technique that samples the fluid around neurons in real time. The levels they found were comparable to serotonin and dopamine, 2 of the most important neurotransmitters in the brain. DMT was not a trace byproduct. It was present at neurologically relevant concentrations. Third, and this is the finding that matters most for our story, they induced cardiac arrest in the rats. And when they did, DMT levels in the visual cortex spiked dramatically. The brain, as it began to die, produced more DMT. And here is the detail that shattered the pineal gland hypothesis as it had been originally conceived. Some of the rats had already had their pineal glands surgically removed. The DMT spike still occurred. The brain itself, not just the pineal gland, was producing and releasing DMT during cardiac arrest. This was a turning point. For decades, the connection between DMT and death had been speculative. Strassman's hypothesis was elegant but unproven. Now there was hard data. DMT is endogenous, meaning the brain makes it naturally. It is present at meaningful concentrations, and its levels rise during the process of dying. In 2018, a year before the Dean study was published, a team led by Christopher Timmerman at Imperial College London conducted another critical experiment. They gave intravenous DMT to healthy volunteers and then asked them to complete a standardized near-death experience questionnaire, the same scale used to evaluate accounts from cardiac arrest survivors. The results were published in Frontiers in Psychology. The overlap was extraordinary. Subjects who had been given DMT reported experiences that mapped almost identically onto the near-death experience scale. Ego dissolution, tunnels of light, encounters with entities, a sense of transcendence, feelings of profound peace and love, the life review, the sense of crossing a threshold. Point by point, the DMT experience and the near-death experience were structurally identical. But the scientific community is cautious for good reason. In 2018, pharmacologist David Nichols published an important critique. He pointed out that the pineal gland weighs less than 0.2 of a gram and produces only about 30 micrograms of melatonin per day. To generate a psychoactive dose of DMT, the brain would need to rapidly produce roughly 25 milligrams. That is nearly 1,000 times more than the pineal gland's daily melatonin output. Furthermore, DMT is rapidly broken down by an enzyme called monoamine oxidase. Even if the brain did produce a surge of DMT at death, it would be metabolized almost immediately. Whether enough could accumulate in the right brain regions at the right time to produce a full psychedelic experience remains genuinely unknown. The truth, as it often does in science, sits somewhere in the middle. DMT is endogenous. The brain makes it. That is confirmed. DMT levels rise during cardiac arrest. That is confirmed. The experiences produced by exogenous DMT are structurally identical to near-death experiences. That is confirmed. But whether the brain produces enough DMT at the moment of death to generate the full spectrum of what near-death survivors describe, that remains an open question. And there is another layer to this. In 2024, a review published in Frontiers in Pharmacology found that DMT interacts with sigma-1 receptors, which are involved in neuroprotection, neuroplasticity, and cell survival. DMT may not just be a molecule that generates visions. It may be a molecule that protects the brain during extreme stress, a chemical last resort, the brain's own emergency system, flooding the cortex with a substance that simultaneously shields neurons from damage and opens the doors of perception as wide as they will go. If that is true, then the dying brain is not hallucinating. It is not malfunctioning. It is doing exactly what it was designed to do, releasing a substance that protects it while simultaneously generating an experience so vivid, so structured, so unlike ordinary consciousness that the people who have it come back permanently changed. Whether that experience is a window into something real or a beautiful chemical farewell, the science cannot yet say. But the brain's own chemistry is telling us something. It is telling us that death is not a passive event. It is an active process, and the brain has been preparing for it all along. Before we go deeper into the mysteries of consciousness and what might survive beyond the body, we need to look at something that most people would rather not think about. Something that challenges every vision of transcendence with the blunt reality of biology. A phenomenon so strange and so unexplained that it has shaken the confidence of neuroscientists who thought they understood how the brain works. People with Alzheimer's disease, people who have not spoken in years, who do not recognize their own children, suddenly waking up and becoming themselves again. Lucid, clear, present, and then dying. It is called terminal lucidity, and it should be impossible. A woman in her 90s had been living with Alzheimer's disease for 9 years. She had not recognized her son in years. She could not tell you where she was. She could not tell you how old she was. She could not form a complete sentence. And then, 24 hours before she died, she woke up. She recognized her family. She knew their names. She knew her own age. She knew the name of the facility she was in. She held a conversation. She was present in a way she had not been in nearly a decade. And then the next morning, she was gone. This is not a fairy tale. This is a documented case cited in the medical literature. And it is not unique. It is one of hundreds, possibly thousands, of similar accounts that have been reported by families and healthcare workers around the world. The phenomenon is called terminal lucidity, and it represents one of the most baffling mysteries in modern neuroscience. Terminal lucidity refers to the sudden, unexpected return of mental clarity in patients with severe, irreversible brain disease, most often occurring hours to days before death. Patients with end-stage Alzheimer's disease who have been nonverbal for months or years suddenly speak. They recognize family members they have not responded to in years. They recall memories that should have been destroyed along with the neural pathways that stored them. They express love, they say goodbye, and then they die. The term terminal lucidity was coined in 2009 by biologist Michael Nahm and psychiatrist Bruce Greyson. Since then, a growing body of research has confirmed that the phenomenon is not rare. A 2021 study by Alexander Bathiany and Bruce Greyson found that in only 6% of paradoxical lucidity cases did the person survive more than a week. This is primarily a death-related phenomenon. It is as if the brain in its final hours performs one last act of restoration. Surveys of healthcare professionals paint a striking picture. In one study, 73% of palliative care workers reported witnessing at least one episode of terminal lucidity in their careers. In a 2025 prospective study led by Sam Parnia's team at NYU Langone Health, researchers tracked over 1,500 patients with moderate to severe dementia. Of the 151 who were enrolled, 61.6% experienced at least one lucid episode. The researchers documented 267 distinct lucid events. These included appropriate orientation to their surroundings, return of old memories, return of functional abilities like walking or playing an instrument, and meaningful nonverbal communication. A 2024 study published in The Gerontologist by Jason Karlawish and colleagues at the University of Pennsylvania conducted in-depth interviews with 30 family caregivers of people with severe dementia. 25 of the 30 described a total of 34 lucid episodes. The episodes were often brief, sometimes lasting only seconds. A single word, a gesture, a facial expression that gave the caregiver a sudden, unmistakable sense that the person inside was still there. One caregiver described a man with severe dementia who had been completely nonverbal for months. On the night before he died, he asked for a cigarette and a beer. He sang songs with his friends and family. He talked and laughed with them for nearly 45 minutes. Then he went to bed. The next morning he was dead. Here is why this matters and why it terrifies neuroscientists. The prevailing model of consciousness in neuroscience is straightforward. Your memories, your personality, your sense of self, all of these are stored in the physical structure of the brain. They are encoded in neural connections, in the synapses between roughly 86 billion neurons linked by an estimated 100 trillion synaptic connections. When those connections are destroyed, the functions they support are destroyed too, permanently, irreversibly. Alzheimer's disease is the most common cause of dementia, and it destroys the brain systematically. Amyloid beta plaques and tau protein tangles accumulate between and inside neurons, disrupting communication, triggering inflammation, and ultimately killing brain cells. In advanced Alzheimer's, the hippocampus, the brain's memory center, is devastated. The cortex, where higher-order thinking occurs, is riddled with damage. Brain scans of patients with end-stage Alzheimer's show massive tissue loss. The brain has physically shrunk. The structures that stored decades of memories are not just damaged. In many cases, they are gone. And yet, terminal lucidity happens. People with brains that have been ravaged by decades of neurodegenerative disease suddenly function as if the damage does not exist. They access memories that should have been destroyed. They demonstrate cognitive abilities that should have been permanently lost. And then they die. How? No one knows. But there are hypotheses. One proposal suggests the spontaneous formation of neural bypasses. Even in severely damaged brains, there may be dormant circuits, silent synapses that can temporarily route around the destroyed pathways and restore connectivity at a network level. Recent research has revealed that the adult cortex contains far more silent synapses than previously believed, by an order of magnitude. These unused connections might, under the right conditions, light up like detour routes on a broken highway. Another hypothesis connects terminal lucidity to the same brain processes we discussed earlier. If the dying brain undergoes disinhibition, removing its natural braking systems, It is possible that this same mechanism could temporarily restore access to memories and cognitive functions that had been suppressed but not fully destroyed by Alzheimer's pathology. The disease may lock the door. The dying process may briefly blow it open. A 2024 perspective published in Molecular Neurodegeneration pointed to an intriguing possibility. Using a specialized brain imaging technique called cyclic amyloid peptide positron emission tomography, researchers discovered that the toxic amyloid beta oligomers in Alzheimer's disease do not accumulate steadily. They fluctuate. Sometimes they clear from specific brain regions temporarily, creating windows where those regions might function more normally. At certain moments, the parietal cortex might be relatively clear while other regions are clouded. Then the pattern shifts. This fluctuation could explain brief, spontaneous episodes of clarity. And here is where the story circles back to DMT. The same 2024 perspective noted that microdosing dimethyltryptamine has been shown in animal models to promote neuroplasticity and potentially reopen the brain's critical learning windows through its interaction with sigma-1 receptors and intracellular serotonin 2A receptors. DMT may have the ability to stimulate the formation of new neural connections even in damaged tissue. If the dying brain releases a surge of endogenous DMT, as the 2019 Dean study showed in rats, could that surge temporarily restore connectivity in a brain devastated by Alzheimer's? It is speculative. It is unproven. But the pieces fit together in a way that demands attention. The dying brain surges with gamma activity. The dying brain releases DMT. And the dying brain sometimes restores cognitive function in people who should have none left. The National Institutes of Health have taken notice. Sam Parnia at NYU Langone Health has received a 5-year grant funded by the National Institute on Aging to conduct the first prospective study of paradoxical lucidity in approximately 500 terminally ill dementia patients. Each patient will be connected to in-home video EEG devices to capture brain activity before, during, and after any lucid episodes. The goal is to determine whether lucidity episodes correlate with specific electrocortical biomarkers, measurable brain signatures that could not only explain terminal lucidity but potentially be used as therapeutic targets for dementia treatment. Think about what that means. If terminal lucidity can be understood mechanistically, if we can identify what the brain does to temporarily restore itself, we might be able to trigger that process deliberately. We might be able to give people with severe dementia back their minds, even briefly. We might be able to let them say goodbye. But there is a deeper question here, one that goes beyond medicine. If a brain ravaged by decades of disease can suddenly function perfectly minutes before death, what does that tell us about where consciousness actually resides? Is it entirely in the neurons? Is it a product of the physical structure of the brain? Or is the brain something more like a receiver, a device that tunes into consciousness the way a radio tunes into a signal? A device that can be damaged and broken and still, in its final moments, pick up the broadcast one last time. We are not ready to answer that question yet, but we are getting closer. And to continue this journey, we need to leave the hospital room and enter a different kind of territory. We need to talk about what happens to the body itself after the last breath. Because the physical reality of death is not poetic. It is not mystical. It is biology at its most honest. And understanding it changes the way you think about everything that comes after. The moment the heart stops, a cascade of physical changes begins. Blood ceases circulating, oxygen delivery halts, and cells, deprived of the energy they need to maintain their membranes and processes, begin to die. But they do not die all at once. The process is gradual, organ by organ, cell by cell. And it happens in stages that forensic scientists have mapped with clinical precision. The first visible change is called pallor mortis. Within minutes of the heart stopping, the body begins to pale. Without circulation, blood drains from the capillaries near the surface of the skin, leaving a waxy, grayish-white appearance. This can happen within 15 to 30 minutes. At the same time, algor mortis begins. The body starts to cool. Without the metabolic heat generated by trillions of living cells, body temperature drops at a rate of roughly 1.5 degrees Fahrenheit per hour, slowly equalizing with the surrounding environment. In a cool room, a body can take 12 to 20 hours to reach ambient temperature. In extreme heat, the process is much faster. Within 20 minutes to 2 hours, livor mortis appears. Without the heart to push it along, blood obeys gravity. It pools in the lowest parts of the body wherever they happen to be. If the body is lying on its back, the blood settles into the back, the buttocks, the shoulders, the calves. It creates dark, purplish discoloration that is visible through the skin. In forensic science, livor mortis is used to determine whether a body has been moved after death. If the lividity does not match the body's position, someone changed something. Then comes rigor mortis. Roughly 2 to 6 hours after death, the muscles begin to stiffen. Here is why. In a living body, muscles contract and relax through a chemical process that requires adenosine triphosphate, ATP, the energy currency of the cell. When a muscle contracts, actin and myosin filaments slide together and lock. To release, ATP must bind to the myosin and break the connection. Without ATP, the connection cannot break. The muscles lock in place. Rigor mortis begins in the small muscles first, the eyelids, the jaw, the neck. It progresses downward through the body over roughly 12 hours until every muscle is stiff. It persists for 24 to 84 hours, depending on temperature and other conditions. Eventually, as cellular decomposition progresses, the bonds break down and the body relaxes again. But even at this stage, not all the cells are dead. Some cells can survive hours after the heart stops. White blood cells in a corpse have been found alive for days. Skin cells can be cultured from cadavers up to 24 hours after death. The boundary between life and death is not a sharp line. It is a gradient, and then the body begins to consume itself. Without oxygen, cells become acidic. Their membranes rupture, and the enzymes that were once contained inside those cells, enzymes whose job it was to break down food and waste, spill out into the surrounding tissue and begin to digest whatever they touch. This process is called autolysis, self-digestion. The pancreas is usually the first organ to go. It is loaded with powerful digestive enzymes, enzymes designed to break down proteins, fats, and carbohydrates. In life, these enzymes are kept carefully contained. In death, they are released. The pancreas essentially digests itself. The liver follows. The brain, soft and rich in water, breaks down quickly. The intestines, already home to trillions of bacteria, begin to dissolve from the inside out. And that brings us to the second wave, the bacteria. In life, your immune system keeps your gut bacteria in check. Roughly 39 trillion bacterial cells live inside a healthy human body, mostly in the intestines. They are not invaders. They are partners. They help you digest food, produce vitamins, and train your immune system. But the moment the immune system shuts down, the partnership ends. The bacteria do not know you are dead. They only know that the barriers that once contained them are gone. The gut bacteria begin consuming the intestinal walls. They spread into the bloodstream, into the organs, into tissue they were never meant to reach. They produce gases as they feed, primarily hydrogen sulfide, methane, and ammonia. Within 3 to 5 days, these gases begin to bloat the body. The abdomen swells. The face puffs. The tongue may protrude. The body can swell to nearly twice its normal size. The gases also produce the characteristic chemicals of decomposition. Putrescine and cadaverine, 2 molecules with names that tell you everything you need to know, are released in increasing quantities. A dark, foul-smelling fluid called purge fluid, a mixture of liquefied tissue, bacteria, and gas, is forced from the nose and mouth. Meanwhile, the outside world has found the body. Blowflies can detect the chemical signature of death from miles away. They arrive within hours, sometimes within minutes, landing on the body and laying eggs in the natural openings. The eyes, the nose, the mouth, any wound. The eggs hatch into maggots within 24 hours. Maggots are the most efficient biological decomposers on the planet. A mass of maggots can raise the temperature of a decomposing body by as much as 10 degrees Celsius through their collective metabolic activity. They consume soft tissue with remarkable speed. Active decay, the phase when the body loses the most mass, typically occurs between weeks 3 and 7. Organs and soft tissue liquefy. The skin darkens and eventually sloughs off. The chemical byproducts of decomposition seep into the surrounding soil, creating what forensic anthropologists call a cadaver decomposition island, a zone of enriched soil that can persist for years. In warm, exposed conditions, a human body can be reduced to a skeleton in as few as 9 days. In temperate climates, the process takes weeks to months. In very cold or very dry environments, decomposition can be dramatically slowed. Mummification, either natural or deliberate, can preserve a body for thousands of years. But under normal conditions, the soft tissue is gone within months. Bones last longer. Protected by their mineral structure, bones can survive for centuries under the right conditions. But even bones are not permanent. Over thousands of years, they too are broken down by water, soil chemistry, and microbial activity. Eventually, every atom that was once you is returned to the ecosystem. And here is where the science becomes strangely poetic. Every atom in your body was forged in the interior of a star. The carbon in your muscles, the calcium in your bones, the iron in your blood, all of it was created in the nuclear furnaces of stars that burned out and exploded billions of years ago. You are not just made of stardust as a metaphor. You are literally constructed from atoms that once existed inside dying stars. In death, those atoms do not vanish. They re-enter the cycle. Within a year of burial, the atoms that were once you are incorporated into soil, into plants, into water, into insects, into the bodies of other organisms. A single human body contains enough carbon, nitrogen, phosphorus, and other elements to sustain an entire meadow ecosystem. Your death feeds new life, not poetically, chemically, measurably, literally. Research at forensic anthropology facilities, sometimes called body farms, has demonstrated that a decomposing body creates a burst of ecological activity. The soil beneath and around a body becomes dramatically enriched. Plant growth in these areas is more vigorous. Microbial diversity increases. The body in death becomes a source of life. The green burial movement and the emerging practice of human composting embrace this reality directly. Rather than embalming the body with formaldehyde, sealing it in a metal casket and placing it in a concrete vault, processes designed to resist decomposition as long as possible, green burial returns the body to the earth as a deliberate act of ecological continuation. Human composting, legalized in a growing number of places, accelerates the process, transforming a human body into nutrient-rich soil in roughly 30 to 60 days. In a purely materialist framework, this is the afterlife. Not heaven, not reincarnation, but redistribution. The atoms that were you become the grass, become the deer that eats the grass, become the soil that feeds the tree, become the air that fills another set of lungs. The cycle does not end, transforms. But the physical story of what happens to the body is only half the story of death. Because long before modern science mapped the process of decomposition, long before forensic anthropology and microbiology, human beings were already asking the question that the body cannot answer. What happens to the part of you that is not the body? The oldest and most elaborate answer to that question comes from the banks of the Nile, from a civilization that spent more time, more wealth, and more creative energy on death than any other culture in human history. A civilization that believed the journey after death was not a metaphor. It was literal. It was dangerous, and it required a map. That civilization was ancient Egypt, and their map of the afterlife is our next destination. 4,000 years ago, on the banks of the Nile, a civilization built its entire culture around a single conviction. Death was not the end. It was a door, a dangerous, terrifying, magnificent door that opened onto a journey through the underworld. A journey that could lead to eternal paradise or to the total annihilation of everything you ever were. The ancient Egyptians did not treat death as an abstraction. They treated it as an engineering problem. They mummified their bodies to preserve them for eternity. They filled their tombs with food, tools, furniture, jewelry, and weapons for the journey ahead. They wrote detailed instruction manuals for the dead, guides packed with spells, passwords, and warnings to help the deceased navigate the horrors that waited on the other side. To understand the Egyptian afterlife, you first need to understand what they believed a human being was. Because in Egyptian thought, you were not one thing. You were many things woven together, and death unraveled them. The Ka was your life essence, your vital force. It was the energy that made the difference between a living body and a corpse. The Ka was born with you, lived with you, and at the moment of death, it separated from the body. It needed sustenance. It needed offerings of food and drink from the living. Without them, the Ka would wither. This is why tombs contain storerooms filled with provisions. This is why families returned to tombs for generations, leaving offerings at altars. They were feeding the Ka. The Ba was your personality, your individual spirit. It was depicted in Egyptian art as a human-headed bird because the Ba was free. After death, the Ba could fly between the world of the living and the world of the dead, could visit the tomb, could see the sun, could travel through the afterlife. But the Ba needed a home to return to, and that home was the preserved body. This is why mummification was so important. Without the body, the Ba had nowhere to rest. The Ak was the ultimate goal. When the Ka and the Ba were successfully reunited in the afterlife, they formed the Ak, the transfigured, luminous, eternal being. The Ak was what you became if you passed the tests. If you failed, you became nothing. The journey to becoming an Ak was not easy. Between death and paradise lay the Duat, the Egyptian underworld, and the Duat was a nightmare. The Duat was not a metaphorical concept. The Egyptians described it in visceral, terrifying detail. It was a vast labyrinth of caverns, rivers of fire, lakes of boiling liquid, and corridors guarded by creatures that defy imagination. Five-headed reptiles, serpents that breathed flame, gatekeepers with knives, demons with the heads of jackals and the bodies of serpents. At every gate, at every passage, at every turn, the dead faced a challenge. And the only way through was knowledge. To pass each gate, you had to speak the correct name of the guardian. You had to recite the correct spell. You had to answer questions truthfully. If you did not know the name, if you could not recite the spell, the guardian would destroy you. Your Ba would be devoured. Your Ka would dissolve. Your name would be erased from existence. And in Egyptian thought, to have your name erased was the worst fate imaginable. It meant you had never existed at all. This is why the Egyptians developed what we call the Book of the Dead. Its original name was the Chapters of Going Forth by Day. It was not a single book. It was a collection of roughly 192 known spells, hymns, instructions, and incantations written on papyrus scrolls and placed inside the coffin or wrapped within the mummy's bandages. No single copy contained all the spells. Wealthy Egyptians commissioned lavishly illustrated, personalized versions. Less wealthy individuals could purchase mass-produced copies with blank spaces where the scribe would fill in the deceased's name. The Book of the Dead evolved over centuries. Its earliest ancestors were the pyramid texts dating to roughly 2400 BCE, carved into the walls of royal tombs and available only to pharaohs. Over time, these became the coffin texts, accessible to the nobility. By the New Kingdom, around 1550 BCE, the Book of the Dead had become available to anyone who could afford a copy. Death in Egypt was democratic, at least on papyrus. But the most famous scene in the entire Egyptian afterlife tradition is the one that waited at the end of the journey. The Hall of Mot, the Hall of Truth. When the deceased finally reached the Hall of Mot, they stood before the greatest tribunal in Egyptian mythology. Osiris, the god of the dead, and himself a resurrected king, sat on his throne. 42 divine judges lined the walls. The goddess Mot, the embodiment of truth, justice, and cosmic balance, presided over the proceedings. And Anubis, the jackal-headed god who guided the dead, stood beside a golden scale. The deceased was required to recite the negative confessions, a litany of 42 sins they claimed not to have committed. I have not stolen. I have not lied. I have not caused suffering. I have not taken what belongs to the gods. One by one, each denial was spoken aloud before the assembled judges. And then came the weighing. Anubis placed the heart of the deceased on one side of the scale. On the other side, he placed the white feather of Mot, the feather of truth. The heart, in Egyptian thought, was the seat of the soul. It contained the record of everything you had done, every act of kindness and every act of cruelty, every truth spoken and every lie told. If the heart was lighter than the feather, if the person had lived a life of sufficient truth and balance, the scale tipped in their favor. They were declared justified. They were permitted to enter the field of reeds, the Egyptian paradise, Sekitaru. An idealized mirror of Egypt itself, eternal springtime, blue rivers, golden fields, boats sailing on calm water, unfailing harvests, blue skies without end. And Shabti servants, small figurines placed in the tomb, would magically come to life to perform any manual labor the deceased might be called upon to do. Even paradise had chores. But in paradise, someone else did them for you. But if the heart was heavier than the feather, if the person had lived a life burdened by cruelty and dishonesty, then Ammit was waiting. Ammit was a chimera, part crocodile, part lion, part hippopotamus. She crouched beside the scale, and when the heart tipped against the dead, she devoured it. And with that, the person ceased to exist. Not punished, not sent to a place of suffering, but annihilated, erased completely. The final death, the death from which there was no return. Now consider this. Recall what near-death experience survivors describe. A panoramic life review in which they relive their entire existence, an experience of their actions evaluated not from their own perspective but from the perspective of everyone they affected, a moral accounting, a weighing of the life lived. The Egyptian Hall of Ma'at is not identical to the modern near-death life review, but the structural parallels are striking. Both involve a moral evaluation of the entire life at the threshold of death. Both involve a judgment rendered not by an external authority but by the weight of your own actions. Both result in one of two outcomes: continuation or dissolution. Did the ancient Egyptians encode something neurologically real into their mythology 4,000 years ago? Did they take the universal human experience of the dying brain, the life review, the moral evaluation, and dress it in the language of gods and scales and feathers? Or is this a coincidence, a cultural construction that happens to mirror the biology? We cannot know, but the pattern will keep appearing, because the Egyptians were not the only ones who mapped the afterlife in extraordinary detail. Half a world away, in the mountains of Tibet, another tradition created its own manual for the dead. A manual that describes the afterlife not as a physical journey through a dangerous underworld, but as a journey through the landscape of your own mind. A journey where everything you see, every god and every demon, every light and every shadow, is a projection of your own consciousness. And if you recognize that, you are free. In the mountains of Tibet, there is a book that is not meant for the living. It is meant for the dead. The Bardo Thodol, known in the West as the Tibetan Book of the Dead, is one of the most extraordinary spiritual texts ever composed. Attributed to the 8th century Buddhist master Padmasambhava, though likely compiled in its current form in the 14th century, it was hidden as a treasure text, what the Tibetan tradition calls a terma, concealed until the world was ready to receive it. The book is not read in silence. It is read aloud. A lama or a family member sits beside the dying person and recites the text as the person takes their final breaths, and then continues reading for hours or days after the death. Because in the Tibetan Buddhist tradition, the person can still hear. Consciousness does not end at the moment of death. It transitions. It enters a gap between one life and the next. That gap is the bardo. The word itself means intermediate state, and according to the Bardo Thodol, the bardo is the most important moment in all of existence. It is the moment when liberation from the cycle of birth and death is possible, if you recognize what is happening, if you understand what you are seeing. If you do not, you are pulled back into another life, another body, another round of suffering and forgetting. The Tibetan model of death is fundamentally different from the Egyptian one. In Egypt, the afterlife was a physical journey through a physical underworld. You fought monsters. You crossed rivers. You spoke passwords to gatekeepers. The dangers were external. In the Tibetan system, the afterlife is entirely internal. Everything you experience after death is a projection of your own mind. The gods are not real gods. The demons are not real demons. They are your own consciousness reflected back at you with terrifying clarity. The Tibetan word for body is lu, which literally means what is left behind. The body is discarded. Consciousness is what continues, and that consciousness passes through 3 stages, 3 bardos, each offering a chance at liberation. The first is the bardo of dying, called the Chikai Bardo. This is the process of death itself, and the Tibetans describe it in extraordinary detail. As the body shuts down, the elements dissolve in sequence. Earth dissolves into water. You feel heavy, as if you are sinking into the ground. Your vision blurs. Water dissolves into fire. Your mouth dries. Your bodily fluids slow. Fire dissolves into air. Your body heat fades. Your breath becomes shallow and labored. Air dissolves into consciousness. The breath stops. And then, at the exact moment of final dissolution, something happens that the Tibetan tradition considers the most significant event in any life. The clear light appears. The clear light is described as the fundamental nature of reality itself. Pure awareness, luminous, empty, boundless. It is not a light that you see. It is the light that you are. The Bardo describes it as the naked, unconditioned mind, free of all thought, all fear, all identity. If you recognize it, if you realize that this light is your own true nature, you are liberated on the spot. The cycle of birth and death ends. You merge with the infinite, but almost no one recognizes it. because the clear light is terrifying in its vastness. It is unfamiliar. It has no edges, no boundaries, no landmarks. Most consciousness, conditioned by a lifetime of habits and attachments, recoils from it. It is too much, too open, too naked. And so the mind pulls back, and the second bardo begins. This is the bardo of Dermata, the Conii bardo. And it is here that the visions begin. The bardo describes waves of light and sound and color erupting in the consciousness of the dead. Peaceful deities appear first, radiating dazzling light in 5 colors, each associated with a different family of Buddhas and a different aspect of awakened consciousness. They are described as beautiful beyond imagination, their faces serene, their bodies luminous. They invite you toward them, but alongside these peaceful visions, there are also terrifying ones. The wrathful deities appear. They are the same enlightened beings, but now wearing masks of ferocity. They have fangs. They are wreathed in flame. They brandish weapons and drink from skull cups filled with blood. They roar. They threaten. And they are just as much a projection of your own mind as the peaceful ones. The critical teaching of the Bardo Thodol is this: none of it is real. Not the peaceful deities, not the wrathful ones, not the lights, not the sounds, not the terrible visions. They are all projections of your own consciousness, reflections of your own mental habits and karmic patterns played back to you on a cosmic screen. If you recognize them as projections, if you see through the illusion, liberation is still possible even at this stage. But if fear takes over, if you run from the wrathful visions instead of recognizing them as yourself, you are pushed into the third and final stage, the bardo of becoming, the Sitpa bardo. In the bardo of becoming, consciousness is confused, frightened, and disoriented. It is blown about by what the text calls the winds of karma, the accumulated momentum of all your actions, thoughts, and habits from your life. You can perceive the world of the living. You can see your family grieving. You can see your body being prepared for burial or cremation. But you cannot communicate. You cannot touch anything. You cannot be heard. And you begin to see flashes of your next life. You are drawn toward another birth. The text describes seeing couples in the act of union and being pulled toward them by desire or aversion. If you feel attraction to the female figure, you will be born male. If you feel attraction to the male, you will be born female. The Bardo Thodol provides detailed instructions at this stage for how to choose a favorable rebirth, what visions to approach and which to avoid, which lights to follow and which to resist. If all opportunities for liberation have been missed, consciousness enters a new womb, a new body forms, a new life begins, and the cycle continues. The psychoanalyst Carl Jung was deeply fascinated by the Bardo Thodol. He wrote a psychological commentary on the first Western translation, published in 1927 by Walter Evans Wentz. Jung saw the bardos not as literal metaphysical stages, but as descriptions of the unconscious mind, maps of the psyche in its rawest state. He found striking parallels between the contents of the Bardo visions and the archetypal imagery that appeared in the dreams and psychoses of his Western patients. And here is where the threads of our documentary begin to converge in a way that is difficult to dismiss. Compare the Bardo descriptions with what we know from neuroscience and psychedelic research. The dissolution of self, the DMT experience begins with the complete dissolution of ego, just as the Chikai Bardo describes the dissolution of the elements. A blinding, overwhelming light, both DMT users and near-death experience survivors describe encountering light of impossible intensity and beauty. The clear light of the Bardo. Encounters with beings, DMT users consistently report meeting entities, presences, beings of extraordinary power and intelligence, the peaceful and wrathful deities of the Bardo. A moral evaluation, near-death survivors describe the life review, a moral accounting of their actions, the karmic reckoning of the Sitpa Bardo. A sense of ultimate reality. Across all these experiences, people report a feeling that what they are seeing is more real than the waking world, not less, more. The scholar Houston Smith wrote that everything we experience in the Bardos is a reflection of our own mental machinations. The Buddhist philosopher Carl Becker went further, arguing that the heavens, judgments, and ghostly scenarios described by other religious traditions have equal claims to validity. The afterlife, he suggested, is culturally relative insofar as its imagery is projected by the perceiver. In other words, maybe the Egyptians and the Tibetans and the near-death survivors and the DMT volunteers are all describing the same thing. The same underlying event, the same neurological process, dressed in different costumes depending on the culture, the era, and the expectations of the dying mind. Or maybe they are describing something that is genuinely there. Something that exists beyond the brain, beyond culture, beyond biology. Something that every human civilization, from the banks of the Nile to the peaks of the Himalayas, has been trying to map for as long as our species has been aware of its own mortality. The Egyptians and the Tibetans gave the most detailed maps, but they were far from the only ones. In the frozen north, the Norse imagined a great hall where the war dead feasted for eternity. In the Mediterranean, the Greeks built a shadowy bureaucracy beneath the earth. And on every continent, in every era, in every language, human beings have imagined what lies beyond the final breath. The Norse did not promise eternity. They promised a job. In the mythology of the Viking Age, the afterlife was not a reward for good behavior. It was not a place of rest. It was preparation for the end of everything. The Norse believed that the universe itself would die, that a final battle called Ragnarok would consume the gods, the giants, the monsters, and the world tree Yggdrasil that held all of creation together. The sun would be swallowed by a great wolf named Fenrir. The serpent Jormungandr would rise from the ocean and poison the sky. Odin, the All-Father, would fall. Thor would fall. The earth would sink into the sea. And the afterlife existed to get ready for that day. When a Norse warrior died in battle, the Valkyries came. These were the choosers of the slain, beautiful and terrifying women who rode winged horses across the battlefield and selected the bravest of the fallen. Half of the chosen were taken to Valhalla, the great hall of Odin. The other half went to Folkvangr, the field of the goddess Freya. Valhalla was enormous. Its rafters were made of spears. Its roof tiles were golden shields. It had 540 doors, each wide enough for 800 warriors to march through side by side. Every day, the warriors of Valhalla, the Einherjar, rose at dawn, put on their armor, and fought each other to the death. Every evening, the dead rose again, their wounds healed, and they sat down to an endless feast. They ate the flesh of a boar named Saramnir, who was cooked and consumed each night and magically restored each morning. They drank mead that flowed from the udders of a goat named Ern, who fed on the leaves of the world tree. It was not paradise. It was boot camp. The warriors were training. They were preparing for Ragnarok, the final battle at the end of all things, when they would march through those 540 doors and fight alongside the gods against the forces of chaos. And they would lose. The Norse knew they would lose. Ragnarok was not a possibility. It was a certainty. The gods would die, the heroes would die, the world would burn, and from the ashes, perhaps something new would begin. But Valhalla was not the only destination. Those who did not die in battle went to hell. And hell, in Norse mythology, was not punishment. It was simply the default. Hell was presided over by a goddess also named Hel, described as half alive and half dead, with one side of her body living flesh and the other side a rotting corpse. Her realm was cold, dim, and joyless, but it was not torture. It was existence without glory, without purpose, without the honor of a warrior's death. The Norse afterlife was unique among world mythologies because it was organized not around morality, but around the manner of death. It did not matter whether you were kind or cruel, honest or deceitful. What mattered was how you died. A warrior who fell in battle went to Valhalla. A farmer who died of old age in his bed went to hell. The same person, depending on their final moment, could end up in either place. Viking funeral practices reflected this worldview. Ship burials placed the dead in vessels stocked with weapons, food, animals, and sometimes sacrificed servants, provisions for the journey and the battle to come. Cremation released the spirit from the body. The flames were not destruction. They were transportation. Now travel south, cross the Alps, follow the Mediterranean coastline to the world of ancient Greece, where death was imagined very differently. The Greek underworld was not a battlefield. It was a bureaucracy. When a Greek died, the soul descended beneath the earth to the realm of Hades, a god so feared that the Greeks rarely spoke his name. The border between the living and the dead was a river, the Styx, and to cross it you needed a ferryman. His name was Charon. He was old, grim, and he required payment. A coin, an obol, was placed in the mouth or on the eyes of the dead before burial. Without the coin you could not cross. You would wander the near shore of the Styx for eternity, unable to enter the underworld and unable to return to the living. Once across, the soul was judged. 3 judges, Minos, Rhadamanthus, and Aeacus, evaluated the life of the dead and assigned them to one of three destinations. Elysium, the Elysian Fields, was paradise reserved for heroes, the virtuous, and those favored by the gods. Elysium was a land of eternal sunlight, gentle breezes, and effortless joy. It was rare. Few qualified. The Asphodel Meadows were the default destination, the Greek equivalent of hell. This was where ordinary souls went, people who were neither great nor terrible. The Asphodel Meadows were gray, quiet, and endlessly monotonous. Not suffering, not joy, just existence, a faded echo of life. And Tartarus was the pit, reserved for the truly wicked and for those who had personally offended the gods. Tartarus was a place of eternal punishment. Sisyphus pushed his boulder up the hill forever, watching it roll back down each time he neared the summit. Tantalus stood in a pool of water beneath branches heavy with fruit, but the water receded when he bent to drink, and the fruit pulled away when he reached for it. Eternal proximity to what you desire, eternal denial. Unlike the Norse system, the Greek afterlife was morally structured. Your destination was determined by how you lived, not how you died. But like the Norse system, it was permanent. There was no redemption in Hades, no second chance. Death was a one-way door. The Greeks embedded death into the cycle of nature through their myths. Persephone, the daughter of Demeter, was abducted by Hades and taken to the underworld. Demeter's grief caused the earth to become barren. Compromise was reached. Persephone would spend part of the year in the underworld and part on the surface. When she descended, winter came. When she returned, spring. Death and renewal, descent and return. The oldest story in the world. Orpheus, the greatest musician who ever lived, descended into the underworld to retrieve his dead wife, Eurydice. His music charmed Hades and Persephone, and they agreed to release her on one condition. Orpheus must walk ahead and not look back until they reached the surface. He almost made it. At the last moment, overcome by doubt, he turned, and Eurydice was pulled back into the darkness forever. The myth of Orpheus is a story about the impossibility of reversing death, about the human desire to bring back what is lost, and about the terrible price of doubt at the threshold. These two traditions, the Norse and the Greek, are among the most well-documented afterlife mythologies in the Western world. But they are far from the only ones. In ancient Mesopotamia, the dead descended to Kur, a dark, dusty underworld where all souls, regardless of virtue, lived as shadowy versions of themselves, eating clay and drinking dirty water. In Hindu tradition, the god of death, Yama, guides the soul to Yamaloka for judgment, and the soul is reborn according to the karma accumulated in life. In Chinese tradition, the dead pass through Diyu, a multi-layered underworld where they are judged and punished for specific sins before being reincarnated. In Aztec tradition, the dead traveled to Mictlan, the deepest level of the underworld, navigating 9 challenging layers over 4 years before reaching their final rest. In indigenous Australian traditions, the spirit returns to the dreaming, the eternal creative dimension that underlies and generates physical reality. And across all of these traditions, despite the vast differences in culture, geography, language, and era, certain patterns recur with eerie consistency. A journey or crossing, a river, a bridge, a tunnel, a passage from one realm to another. Guides, Anubis in Egypt, Hermes in Greece, the Valkyries in Scandinavia, Yama in Hindu tradition, beings whose role is to escort the dead to their destination. The technical term is psychopomp, moral judgment or evaluation, the weighing of the heart, the life review, the 3 judges of Hades, the karmic accounting, multiple possible destinations, paradise or annihilation, Elysium or Tartarus, Valhalla or hell, heaven or dissolution, and the importance of proper death rites performed by the living, coins for Sharon, offerings for the Ka, prayers read aloud in the Bardo, funeral feasts for the Norse. These patterns predate contact between cultures. The Aztecs never met the Egyptians. The Aboriginal Australians never met the Greeks. The Norse never met the Hindus, and yet they all arrived at the same basic architecture for the afterlife. A journey, a guide, a judgment, a destination. Why? There are 2 possible explanations. The first is neurological. If the dying brain generates a consistent set of experiences, as the gamma wave studies and near-death research suggest, then every culture is simply encoding the same biological event in different symbolic language. The tunnel is universal because the optic nerve misfires the same way in every human brain. The life review is universal because the hippocampus activates the same way in every dying cortex. The beings of light are universal because gamma surges in the temporoparietal occipital junction produce the same hallucinations regardless of whether you worship Osiris or Odin. The second explanation is that they are all describing something real, something that exists beyond culture, beyond biology, beyond the physical structure of the brain, something that every human civilization has glimpsed at the threshold of death and tried to capture in myth and ritual and sacred architecture. We cannot yet determine which explanation is correct, but the pattern is there, and it does not stop with the ancient world. The three largest religions on earth today, Christianity, Islam, and Judaism, collectively followed by over 4 billion people, have their own answers to the question of what happens after death. And their answers share more with the ancient traditions than most believers realize. Roughly 4 billion people alive today follow one of three religions that trace their origins to the patriarch Abraham: Christianity, Islam, and Judaism. Between them, they account for more than half the population of the earth. And all three have placed death at the very center of their theology. Christianity is the largest religion on the planet, with approximately 2.4 billion adherents, and its entire theological structure revolves around a single event: a death and what came after it. The central claim of Christianity is that Jesus of Nazareth, crucified by the Roman authorities in approximately 33 CE, rose from the dead 3 days later. This resurrection is not treated as a metaphor or a spiritual teaching. In mainstream Christian doctrine, it is a historical event. The body that was placed in the tomb walked out of it. And this event, Christians believe, changed the nature of death forever. Because of the resurrection, Christianity teaches that death is not the end for anyone. At the second coming of Christ, all the dead will be raised. Not just their souls, but their bodies. This is the doctrine of bodily resurrection, and it distinguishes Christianity from many other afterlife traditions. The promise is not just spiritual survival. It is physical restoration. A new body, a glorified body, a body freed from disease, decay, and death. Upon resurrection, the dead face judgment. The righteous are granted eternal life in the presence of God. The unrighteous are separated from God permanently. The precise nature of this separation varies enormously across Christian traditions. Some interpret it as literal fire and eternal torment. Others interpret it as the absence of God's presence, a spiritual condition rather than a physical punishment. The Catholic tradition includes purgatory, a temporary state of purification where souls that are destined for heaven are cleansed of remaining sin. Protestant traditions generally reject purgatory, holding that salvation is determined at the moment of death. The Western imagination of heaven and hell has been profoundly shaped by a poem. In 1320, the Italian poet Dante Alighieri completed the Divine Comedy, a journey through 3 realms of the afterlife, 9 concentric circles of descent, each punishing a different category of sin with increasing severity, 7 terraces of purgatory, each purging a different spiritual failing, and 9 celestial spheres of heaven ascending toward the ultimate vision of God. Dante's vision was literary, not doctrinal, but its influence on the Christian imagination has been incalculable. When most people in the Western world picture the afterlife, they are picturing something closer to Dante than to the Bible itself. The Bible's own descriptions of the afterlife are remarkably sparse. Jesus speaks of the kingdom of God, of many mansions in his Father's house, of outer darkness and weeping and gnashing of teeth. But the detailed geography that most Christians carry in their minds comes from centuries of theological elaboration and artistic interpretation built upon these relatively brief passages. Islam is the world's second largest religion, with approximately 1.9 billion adherents. Its eschatology, its theology of the end times and the afterlife, is among the most detailed of any world religion, described in extensive passages in the Quran and elaborated further in the Hadith, the collected sayings and traditions of the Prophet Muhammad. In Islamic teaching, the moment a person dies, the soul enters an intermediate state called barzakh. This is not the final destination. It is a waiting room. In the grave, 2 angels named Munkar and Nakir visit the deceased and ask 3 questions. Who is your Lord? What is your religion? Who is this man who was sent among you? The righteous answer correctly and are shown a glimpse of paradise. The wicked cannot answer and are shown a glimpse of their punishment. The barzakh continues until the day of judgment, when all souls are resurrected and brought before God for final accounting. The imagery of that day is vivid. Every person's deeds are recorded in a book. The book is opened, and the deeds are weighed on a cosmic scale called the mizan. Good deeds on one side, sins on the other. The parallel to the Egyptian weighing of the heart is striking. A scale, a morale counting, the weight of your life measured against a standard of divine justice. Different cultures, different centuries, different continents, same structure. After the weighing, the dead must cross as sirat, a bridge over the fires of punishment. The bridge is described in the Hadith as thinner than a hair and sharper than a sword. The righteous cross it with ease, some at the speed of lightning. The wicked stumble and fall. The bridge is not a metaphor. In Islamic tradition, it is a real test, a physical crossing that separates the saved from the condemned. Paradise in Islam is called Jannah, and it is described with lavish sensory detail. Gardens beneath which rivers flow, rivers of water, of milk, of honey, and of wine that does not intoxicate. Fruits of every kind, garments of silk, reunion with loved ones, and the greatest reward of all, the beatific vision, seeing the face of God. The punishment of Jahannam is described with equal specificity. Fire, boiling water, chains, trees with fruit like the heads of demons. The suffering is proportional to the sins committed. Among Islamic scholars, there is active debate about whether Jahannam is eternal for all its inhabitants, or whether Muslim sinners serve a finite sentence before being admitted to paradise. The majority view holds that believers will eventually be released, while those who rejected faith entirely face permanent separation from God. Judaism, the oldest of the three Abrahamic faiths, takes a notably different approach. Where Christianity and Islam provide elaborate maps of the afterlife, Judaism largely declines to draw one. The Hebrew Bible, the Tanakh, contains remarkably few references to what happens after death. The word Sheol appears throughout the text, but it is not a place of punishment. It is a shadowy, indistinct realm where the dead exist in a diminished state. The Psalms describe Sheol as a place of silence where the dead do not praise God. It is closer to the Greek asphodel meadows than to any concept of heaven or hell. Later Jewish thought, particularly in the rabbinic period, developed more detailed concepts. Olam haba, the world to come, is a future state of perfection that will be established after the coming of the Messiah. Gan Eden, the Garden of Eden, is a paradise for the righteous, and Gehinnom is a purgatorial state. But unlike the Christian concept of hell, Gehinnom is typically described as lasting no more than 12 months. It is a process of spiritual cleansing, not eternal torment. The resurrection of the dead is part of traditional Jewish belief. It appears in the 13 Principles of Faith compiled by the medieval philosopher Maimonides. But the details are left deliberately vague. Judaism's emphasis is consistently on how to live, not on mapping the afterlife. There is a famous Talmudic attitude that captures this perfectly. We were given the Torah for this world. Let God take care of the next. Now step back and look at all three traditions together. Despite their theological differences, the structural similarities are remarkable. All three feature a moral judgment after death. All three include an intermediate state between death and the final reckoning. All three describe a weighing or evaluation of deeds. All three promise a paradise for the righteous and consequences for the wicked. All three affirm bodily resurrection in some form. And all three rest on the same Near Eastern cultural foundation that produced the Egyptian Hall of Mot thousands of years before any of them existed. The scales of Anubis and the mizan of Islam. The negative confessions and the Last Judgment. The field of reeds and Jannah. The patterns rhyme across millennia. For billion people live their lives according to these answers. They shape their morality, their relationships, their hopes, and their fears around the conviction that death is not the end, that what you do in this life determines what happens in the next, that someone is watching, that the scales are real. Whether these beliefs are true descriptions of an actual afterlife or cultural elaborations of a universal neurological experience, they carry real weight in the real world. They comfort the dying. They restrain the living. They give meaning to suffering and hope to grief. And they have done so for thousands of years. But there is another way to approach the question of what happens after death. Not through religion, not through mythology, but through the deepest and most unsettling question in all of science. A question that no laboratory has answered. A question that no equation has solved. A question so fundamental that it undermines everything we think we know about the relationship between the brain and the mind. What is consciousness? Where does it come from? And can it survive the destruction of the organ that appears to produce it? In 1995, a philosopher named David Chalmers stood before a room full of scientists and asked a question that none of them could answer. He called it the hard problem of consciousness. And 3 decades later, it remains unsolved. The question is simple. Why does subjective experience exist at all? We can map the brain down to the individual neuron. We can track electrical signals across the cortex in real time. We can identify which regions activate when you see red, taste chocolate, hear music, or feel grief. We can describe the mechanics of consciousness with extraordinary precision. But we cannot explain the one thing that matters most. Why is there something it is like to be you? When light hits your retina, photoreceptor cells convert it into electrical signals. Those signals travel through the optic nerve to the visual cortex, where they are processed through a hierarchy of neural circuits that extract edges, colors, motion, and depth. We can describe every step of that process, but none of it explains why you experience the color red. Why there is a qualitative, subjective feeling associated with seeing it. Why you do not simply process the light the way a camera does, recording the wavelength without experiencing anything at all. Chalmers distinguished between the easy problems of consciousness and the hard problem. The easy problems are not actually easy. They are enormously complex. But they are easy in principle because they are problems about function. How does the brain process sensory information? How does it integrate data from different modalities? How does it direct attention? How does it generate behavior? These are engineering questions. With enough time and technology, we can answer them. The hard problem is different. The hard problem asks why any of that functional processing is accompanied by experience. Why is there an inner life? Why are we not what Chalmers called philosophical zombies? Biological machines that process information and generate behavior identically to conscious beings, but without any subjective experience. From the outside, a zombie would be indistinguishable from a conscious person. It would walk, talk, laugh, cry, and claim to have feelings, but inside there would be nothing. No one home. The mainstream view in neuroscience, and the dominant view in Western science since the Enlightenment, is that consciousness is produced by the brain. It is a product of neural activity. When neurons fire in certain patterns, consciousness emerges the way wetness emerges from water molecules. It is what the brain does the way digestion is what the stomach does. Francis Crick, the co-discoverer of the structure of DNA, put it bluntly in his 1994 book, The Astonishing Hypothesis. You, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will, are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. You are nothing but a pack of neurons. This is the materialist position. Consciousness equals brain activity. Destroy the brain, destroy consciousness. Death is the permanent end of subjective experience. It is a powerful framework. It is supported by enormous amounts of evidence. Brain injuries change personality. Drugs alter consciousness. Specific brain regions are reliably associated with specific mental functions. Damage to the hippocampus destroys the ability to form new memories. Damage to the fusiform gyrus destroys the ability to recognize faces. Damage to Broca's area destroys the ability to produce speech. The correlation between brain structure and mental function is so consistent and so well documented that most neuroscientists consider it case closed. The brain makes the mind. But there is a problem. And the problem has been growing for decades. Despite more than a century of neuroscience, despite brain imaging technology that can track neural activity at the millisecond level, despite the mapping of the entire human genome and the identification of genes associated with neurological function, no one has produced a theory of consciousness that explains how subjective experience arises from physical processes. The correlation between brain activity and conscious experience is beyond dispute. But correlation is not causation, and the explanatory gap between neural activity and subjective experience remains as wide as it was when Chalmers named it in 1995. This is not a fringe concern. It is acknowledged by leading neuroscientists. Christoph Koch, the former chief scientist of the Allen Institute for Brain Science and one of the most prominent consciousness researchers in the world, has described the problem as the most fundamental unsolved question in all of science. We know more about the physics of black holes than we do about the nature of the experience you are having right now as you listen to these words. And into this gap, a very old idea has been re-emerging, not from mystics or philosophers, but from the edges of mainstream science. The idea that the brain does not generate consciousness, it receives it. The brain as receiver hypothesis is not new. William James, the father of American psychology, proposed a version of it in 1898. He argued that the brain may transmit consciousness the way a prism transmits light. The prism shapes the light, filters it, it breaks it into colors. But the prism does not create the light. The light exists independently. Destroy the prism, and the light is not destroyed. It simply passes through unfiltered. Aldous Huxley expanded on this idea in the 1950s. He proposed that the brain functions as a reducing valve, filtering the overwhelming totality of consciousness down to a manageable trickle that allows us to survive in the physical world. Psychedelic drugs, he suggested, temporarily open the valve, allowing more of the signal through, and death, he speculated, removes the valve entirely. This hypothesis remains a minority view in neuroscience. Most researchers consider it unfalsifiable and therefore unscientific, but it has never been refuted. And certain observations we have already discussed in this documentary, are very difficult to explain under the standard materialist model. Terminal lucidity, a brain destroyed by decades of Alzheimer's disease suddenly producing perfect cognition. If consciousness is generated by neural circuits and those circuits are physically destroyed, how does the mind come back? Verified near-death perceptions, patients accurately describing events that occurred while their brains were flatlined. If consciousness requires a functioning brain, how did they acquire information when the brain was not functioning? And the measurement problem in quantum physics, at the quantum level, the act of observation appears to affect physical reality. Particles exist in superpositions of multiple states until they are measured. The observer, in some interpretations of quantum mechanics, is not a passive recorder of reality but a participant in creating it. None of these observations prove the receiver hypothesis. None of them disprove materialism, but they create cracks, and through those cracks, questions leak in. If consciousness is generated by the brain, then death is annihilation. The generator is destroyed. The electricity stops. The lights go out. Nothing remains. If consciousness is received or filtered by the brain, then death is the destruction of the receiver, not the signal. The radio breaks. The music does not stop. It simply is no longer being translated into a form we can hear. Neither position has been scientifically proven. The materialist position is an assumption supported by correlation, not a demonstrated mechanism. The receiver position is a hypothesis supported by anomalies, not a demonstrated mechanism. We do not know which is true, but one Nobel Prize-winning physicist believed that the answer might lie in a place no one had thought to look. Inside the smallest structures of the cells that make up your brain, in the quantum vibrations of protein tubes so tiny they exist at the boundary between classical physics and the strange probabilistic world of quantum mechanics. His theory is controversial. His predictions are being tested right now in laboratories around the world. And if he is right, consciousness is not a byproduct of computation. It is woven into the fabric of the universe itself. In the 1990s, two scientists from very different fields formed an unlikely partnership. One was Roger Penrose, a mathematician and physicist at the University of Oxford, a man who would go on to win the Nobel Prize in Physics in 2020 for his work proving that black holes are a necessary consequence of general relativity. The other was Stuart Hameroff, an anesthesiologist at the University of Arizona, a man who had spent his career studying the mechanics of how the brain loses and regains consciousness under anesthesia. Together, they proposed a theory of consciousness that shocked the scientific world. They called it orchestrated objective reduction, or orchestroar, and at its core was a claim that most neuroscientists considered absurd. Consciousness, they argued, does not emerge from the computational complexity of neural networks. It arises from quantum processes occurring inside tiny structures within neurons called microtubules. Microtubules are hollow protein cylinders found in virtually every cell in your body. They are part of the cytoskeleton, the internal scaffolding that gives cells their shape and structure. For decades, they were considered purely structural, the beams and girders of cellular architecture. But Hameroff had noticed something. Microtubules do far more than hold cells together. They regulate synaptic connections. They control cell growth and division. They transport materials within the cell. And in neurons specifically, they play a role in how signals are processed and transmitted. Hameroff also noticed something else. When you go under general anesthesia, you lose consciousness. The anesthetic molecules do not shut down your brain. Your neurons keep firing. Your brainstem keeps your heart beating and your lungs breathing. But consciousness vanishes. And many anesthetic agents, Hameroff observed, bind specifically to microtubules. They interact with the proteins inside these structures. Could microtubules be the seat of consciousness rather than just structural support? Penrose brought the physics. He had long been troubled by a problem in quantum mechanics. In the quantum world, particles can exist in superpositions, simultaneously occupying multiple states until they are observed or measured, at which point they collapse into a single definite state. This is the famous measurement problem. Penrose proposed that this collapse, this reduction from many possibilities to one definite reality, is not caused by observation alone. It is caused by an objective physical process related to the curvature of spacetime at quantum scales. He called this objective reduction. Combine Hameroff's microtubules with Penrose's physics, and you get orchestroar. The theory proposes that quantum superpositions build up within the tubulin proteins of microtubules inside neurons. These superpositions are not random. They are orchestrated by biological processes, by the computational activity of the neural network. When the superpositions reach a critical threshold determined by quantum gravity, they collapse. They undergo objective reduction, and each collapse is a moment of conscious experience. In this framework, consciousness is not something the brain computes. It is something the brain tunes into. Each moment of awareness is a quantum event, a collapse of possibility into actuality, occurring billions of times per second across billions of microtubules in billions of neurons. Consciousness is not an emergent property of complexity. It is a fundamental feature of the universe, and the brain is the instrument that accesses it. The scientific community reacted with intense skepticism. The main objection was environmental. The brain is warm, wet, and noisy. Quantum coherence, the maintenance of quantum superpositions, was believed to be impossible in such an environment. Quantum effects were thought to require near-absolute zero temperatures and total isolation from external disturbance. A brain at 37 degrees Celsius, saturated in biochemical activity, seemed like the last place you would find quantum processes. For years, orchestroar was treated as an interesting but implausible speculation. And then the evidence started to arrive. In 2024, researchers at Wellesley College conducted an experiment with rats. They administered a drug called apothalone B, which binds to and stabilizes microtubules. The rats that received the drug took over a minute longer to lose consciousness under anesthesia compared to control animals. If microtubules were purely structural, stabilizing them should not affect the onset of anesthesia. But it did. The implication was that microtubules play an active role in maintaining consciousness. In 2025, Hameroff and colleagues published a paper in Neuroscience of Consciousness, an Oxford University Press journal, presenting what they described as direct experimental evidence of quantum effects in microtubules at room temperature. The paper also presented magnetic resonance imaging evidence suggesting the existence of a macroscopic quantum state related to consciousness in the human brain. The same paper argued that orchestroar solves two long-standing problems in the science of consciousness: the binding problem, which asks how the brain combines disparate sensory inputs, sight, sound, touch, smell, into a single unified conscious experience, and the problem of epiphenomenalism, which asks how consciousness, if it is merely a byproduct of physical processes, can have any causal effect on the physical world. If consciousness is a quantum phenomenon, it operates at the most fundamental level of physical reality and can influence events through quantum effects. What about the objection that the brain is too warm and noisy for quantum coherence? Recent research in quantum biology has been steadily undermining that assumption. Quantum coherence has been demonstrated in photosynthesis, in the navigation systems of migratory birds, and in the olfactory system that allows you to distinguish smells. Biology, it turns out, may have evolved to exploit quantum effects in warm, wet environments. The brain may be no exception. In Italy, the underground Gran Sasso National Laboratory tested gravity-related quantum collapse models. The simplest version of these models was ruled out by the experimental data, but Penrose's original formulation was not excluded. Refined models consistent with orchestroar remain viable. The door is open. Now, here is what this means for death. If consciousness is a quantum phenomenon, if it arises from quantum processes in microtubules, then the information that constitutes your conscious experience is fundamentally quantum in nature. And one of the most profound principles of quantum mechanics is that quantum information cannot be destroyed, can be transformed, can be scattered, it can be scrambled beyond any practical hope of recovery, but it cannot be annihilated. Hameroff has speculated openly about the implications. When a person dies, he has said, the quantum information in their microtubules does not disappear. It dissipates into the universe. If the patient is resuscitated, that quantum information can flow back into the microtubules, and the person reports a near-death experience. If the patient is not resuscitated, the quantum information exists outside the body, perhaps indefinitely, as what Hameroff has called a soul. Penrose himself is more cautious. He does not endorse the soul language. He has said that the relationship between consciousness and quantum gravity is something that we are only beginning to understand. But he has not dismissed the possibility that consciousness has a deeper relationship to the physical universe than current neuroscience assumes. Orchestroar remains deeply contested. Many neuroscientists consider it speculative at best. But it is the only theory of consciousness that makes specific, testable predictions about the relationship between quantum physics and subjective experience. And those predictions are being tested right now in labs around the world. We are in the earliest stages of understanding whether consciousness has quantum roots. But if it does, the implications for death are staggering. Because if consciousness is not generated by the brain but accessed through it, if it is woven into the fabric of spacetime itself, then the death of the brain is not the death of consciousness. It is the destruction of the antenna. The signal continues. And there is one more theory we need to examine. A theory proposed not by a physicist or a philosopher, but by a biologist, a stem cell researcher named one of the 100 most influential people in the world by Time magazine. A man who looked at quantum mechanics, looked at consciousness, looked at the nature of reality itself, and arrived at a conclusion so radical that it overturns everything we think we know about the relationship between life and the universe. His name is Robert Lanza, and his theory says that death does not exist at all. Robert Lanza is not a mystic. He is not a philosopher. He is a scientist, a stem cell researcher whose work has been recognized by the National Institutes of Health, the National Academy of Sciences, and Time magazine, which named him one of the 100 most influential people in the world in 2014. He has published hundreds of peer-reviewed papers. He has pioneered techniques in regenerative medicine. His credentials in mainstream biology are impeccable. And in 2009, he published a book that proposed something that most of his colleagues considered outrageous. The book was called Biocentrism, and its central claim was this: life and consciousness are not products of the universe. They are the foundations of it. The conventional view of reality goes like this: the universe came first. 13.8 billion years ago, the Big Bang created space, time, matter, and energy. Over billions of years, stars formed, planets coalesced, chemistry became biology, and eventually, on at least one small planet orbiting an ordinary star, life emerged. Consciousness is a late arrival, a product of evolution, an emergent property of sufficiently complex brains. The universe does not need consciousness. Consciousness is an accident, a byproduct, a passenger on a bus that was going somewhere anyway. Lanza turned this entirely upside down. He argued that consciousness does not emerge from the universe. The universe emerges from consciousness. Space and time are not objective realities that exist independently of observation. They are tools of biological perception. They are the way consciousness organizes its experience. Without an observer, Lanza argued, space and time have no independent existence. This sounds like philosophy, but Lanza grounded his argument in physics, specifically in the most famous experiment in quantum mechanics, the double-slit experiment. Here is the experiment in its simplest form. You fire individual particles, photons or electrons, at a barrier with two slits in it. Behind the barrier is a detection screen that records where each particle lands. If particles were just particles, little bullets of matter, you would expect to see two bands on the screen, one behind each slit. But that is not what happens. The particles create an interference pattern, a series of alternating light and dark bands that is characteristic of waves. Each particle somehow passes through both slits simultaneously, interferes with itself, and lands in a pattern that only makes sense if it traveled as a wave. But here is where it gets strange. If you set up a detector at the slits to observe which slit each particle passes through, the interference pattern disappears. The particles behave like particles again. Two bands. No wave pattern. The act of observation changes the behavior of the physical system. This is not disputed. It has been replicated thousands of times in laboratories around the world. It is one of the most well-established results in all of physics, and it raises a question that physics has never satisfactorily answered. What role does the observer play in determining reality? Lanza took this question and ran with it. If observation affects reality at the quantum level, and if the quantum level is the foundation of all physical reality, then the observer is not separate from the universe. The observer is integral to it. Consciousness is not a product of the physical world. The physical world is a product of consciousness. And if consciousness is fundamental, if it is the ground floor of reality rather than the penthouse, then it cannot be destroyed by the death of any particular biological body. The body is a temporary vehicle. Consciousness is what drives it. When the vehicle breaks down, the driver does not disappear. Lanza combined this with the many worlds interpretation of quantum mechanics, a mainstream interpretation proposed by physicist Hugh Everett in 1957. The many worlds interpretation holds that every quantum event causes the universe to split into multiple branches, each representing a different possible outcome. In this framework, every possible version of reality exists simultaneously in an infinite branching tree of parallel universes. Lanza's extension was elegant and unsettling. When you die in one branch of the multiverse, consciousness simply continues in another branch where you are still alive. Death is real for the body. It is not real for consciousness. From the perspective of the observer, from the perspective of the mind, death never happens. You simply find yourself in the next moment in another version of reality where the fatal event did not occur. He found support for this idea in an unlikely place. In a letter written by Albert Einstein in 1955, Einstein's lifelong friend Michel Besso had died. Einstein wrote a condolence letter to Besso's family that has become one of the most quoted passages in the history of physics. "Now Besso has departed from this strange world a little ahead of me," Einstein wrote. "That means nothing. People like us know that the distinction between past, present, and future is only a stubbornly persistent illusion." Einstein was not being mystical. He was being precise in the framework of relativity, which Einstein himself created. Time does not flow the way we experience it. Past, present, and future all exist simultaneously in what physicists call the block universe. The distinction between them is a feature of perception, not of physics. Death, in this view, is an event that occurs at a specific point in spacetime. But the person exists at other points in spacetime as well. And from the perspective of physics, all of those points are equally real. Lanza also pointed to the first law of thermodynamics. Energy cannot be created or destroyed, can only change form. The human brain generates roughly 20 watts of electrochemical energy. When the brain dies, that energy does not vanish. It must take another form. It dissipates as heat. It is absorbed by the surrounding environment, but it does not cease to exist. Energy is conserved. The criticism of biocentrism has been fierce. Theoretical physicist Lawrence Krauss dismissed it, saying he saw no scientific breakthroughs in the theory. Philosopher Daniel Dennett called it the opposite of a theory, arguing that Lanza does not explain how consciousness happens at all. And many physicists have pointed out that the role of the observer in quantum mechanics is far more nuanced than Lanza's account suggests. The observer in quantum mechanics does not have to be a conscious being. A detector, a piece of measuring equipment, anything that interacts with a quantum system can cause wave function collapse. Consciousness may not be special in the way Lanza claims. These are legitimate criticisms. Biocentrism remains more philosophy than testable science. It makes few predictions that can be experimentally verified or falsified. And in science, a theory that cannot be tested is a theory that cannot be confirmed. But biocentrism does something that mainstream physics has failed to do. It takes the observer problem seriously. It takes the hard problem of consciousness seriously. It synthesizes quantum mechanics, consciousness research, and the nature of time into a coherent framework that addresses the deepest questions about reality and death. And for many people, it offers what religions have always offered, the possibility that death is not the end, but framed in the language of science rather than faith. Whether through quantum mechanics, biocentrism, or Buddhist philosophy, a growing number of frameworks propose that consciousness is more fundamental than matter. That the universe is not a machine that accidentally produced minds, but that minds are the foundation upon which the universe is built. And that death, whatever it does to the body, may not touch the thing that matters most. But we should not get lost in theory, because there is one thing that science knows for certain about what happens after death. One thing that is measurable, observable, and undeniable. And it is not about consciousness or souls or quantum mechanics. It is about atoms, about the physical stuff you are made of, and what happens to it when you are gone. Let us talk about what we know, not what we believe, not what we hope, not what we theorize, but what we know. The first law of thermodynamics states that energy cannot be created or destroyed, can only change form. This is not a theory. It is one of the most fundamental and well-tested principles in all of science. No experiment has ever violated it. No observation has ever contradicted it. Energy is conserved, always. Your body is energy. Every cell, every molecule, every atom in you is a form of energy organized into a specific pattern. The pattern is you, your face, your voice, your memories, your personality, the way you laugh, the things you fear. All of it is information encoded in the arrangement of roughly 7 octillion atoms, a 7 followed by 27 zeros, held together by chemical bonds and electromagnetic forces. When you die, the pattern dissolves, but the atoms do not. Not a single one of them disappears. They cannot. The first law forbids it. Every atom that was part of you continues to exist. It simply becomes part of something else. And here is the part that most people do not think about. Those atoms were never really yours to begin with. Every atom in your body was forged in the interior of a star. The hydrogen in the water that makes up 60% of your body was created in the first minutes after the Big Bang, roughly 13.8 billion years ago. The carbon in your muscles, the nitrogen in your DNA, the calcium in your bones, the iron in your blood, all of these heavier elements were produced in the nuclear furnaces of massive stars. Stars that burned for millions of years and then exploded in supernovae, scattering their elemental remains across the galaxy. Those remains coalesced into new stars, new planets, and eventually into the thin film of biology that covers the surface of this particular rock orbiting this particular star. You are not metaphorically made of stardust. You are literally constructed from the debris of exploding stars. The calcium in your right hand may have come from a different supernova than the calcium in your left. The atoms in your body are older than the Earth itself. They were old when the dinosaurs walked. They were old when the first single-celled organism divided in a warm pool 3.8 billion years ago. And they will be here long after you are gone. When you die, whether your body is buried, cremated, or composted, those atoms re-enter the cycle. In burial, decomposition breaks down the complex molecules of your body into simpler compounds. Carbon dioxide is released into the atmosphere. Nitrogen and phosphorus seep into the soil. Water evaporates or percolates into the groundwater. Within a year, the atoms that were once you are incorporated into the soil, into plants, into insects, into the bodies of other organisms. A tree growing above a grave is, in a very real chemical sense, built in part from the person buried beneath it. In cremation, the process is faster. The intense heat breaks molecular bonds and converts organic matter into carbon dioxide, water vapor, and mineral ash. The gases disperse into the atmosphere. The carbon that was once part of your lungs might be absorbed by a forest 1,000 miles away. The water molecules that once carried oxygen through your bloodstream might fall as rain on a field in another country. The ash, rich in calcium phosphate, can be scattered or buried, returning minerals to the earth. A single human body contains enough carbon to make 900 pencils, enough phosphorus to make 2,200 match heads, enough iron to make a small nail, enough potassium to fire a toy cannon, enough sulfur to rid a dog of fleas. These numbers are whimsical, but the underlying truth is not. You are a temporary arrangement of common elements. And when the arrangement ends, the elements continue. Research at forensic anthropology facilities has documented this in detail. A decomposing body creates what scientists call a cadaver decomposition island. The soil beneath and around the body becomes dramatically enriched with nutrients. Nitrogen levels spike. Microbial diversity explodes. Plant growth in the immediate area becomes visibly more vigorous, sometimes for years after the body is gone. Your death does not just feed new life. It creates an island of fertility, a burst of ecological energy that radiates outward from the point where you return to the earth. The green burial movement embraces this reality. Instead of embalming the body with formaldehyde, a toxic preservative designed to delay decomposition, and sealing it in a metal casket inside a concrete vault, green burial allows the body to decompose naturally. The body is wrapped in a simple shroud or placed in a biodegradable container and buried in shallow soil. No chemicals, no concrete, no barriers between the body and the earth. The decomposition is rapid, complete, and ecologically productive. Human composting, which has been legalized in a growing number of jurisdictions, takes this further. The body is placed in a vessel with organic materials such as wood chips, alfalfa, and straw. Over a period of roughly 30 to 60 days, thermophilic bacteria break down the body at elevated temperatures, producing nutrient-rich soil. The soil can be used to grow gardens, restore forests, or nourish landscapes. You become, quite literally, the ground from which new life grows. In a purely materialist framework, this is the afterlife. Not a place you go, but a process you become. The redistribution of your matter and energy into the ongoing story of life on Earth. The carbon cycle, the nitrogen cycle, the water cycle, these are not abstractions. They are the mechanisms by which your atoms will travel through the biosphere for millions of years after you are gone. But there is a loss here that physics cannot address. And it is the loss that most people actually grieve. It is not the atoms. Nobody mourns the carbon. What people mourn is the pattern, the specific arrangement of matter and energy that was you, your personality, your memories, your sense of humor, the sound of your voice, the way you looked when you were thinking. The information. Information theory tells us that the information encoded in your brain, the roughly 86 billion neurons connected by approximately 100 trillion synaptic connections that stored your entire life, your memories, your skills, your identity, appears to be destroyed at death. The neural networks degrade. The synapses dissolve. The electrical patterns cease. The specific configuration that was you is lost. This is the hardest thing for many people to accept. Not that the body dies. We can understand that the body is obviously temporary. What is harder is the idea that the pattern, the you of you, dissolves irreversibly. However, quantum mechanics offers a curious footnote. The no-hiding theorem, a principle in quantum information theory, states that quantum information cannot be completely destroyed, can be scrambled, can be dispersed. It can be transformed beyond any practical possibility of recovery. But it cannot be annihilated. The information is always somewhere. This principle underlies one of the great debates in theoretical physics, the black hole information paradox, which asks whether information that falls into a black hole is truly lost or is somehow preserved. The current consensus, following decades of work by Stephen Hawking and others, is that information is conserved. Whether this abstract conservation of quantum information has any relevance to personal consciousness is unknown. The gap between the preservation of quantum information in the mathematical sense and the survival of your subjective experience as a person is vast. But it is worth noting that even at the most fundamental level of physics, the universe appears to be reluctant to lose information entirely. Here is what we can say with certainty. You have already died and been reborn countless times. The atoms in your body are replaced continuously. Your cells divide and are replaced. Your skin is entirely new every 2 to 3 weeks. Your red blood cells are replaced every 4 months. Your skeleton is fully remodeled every 10 years. The you who exists right now is not materially the same you who existed 7 years ago. Almost every atom has been swapped out, and yet you persist. Your sense of continuity, your feeling of being the same person you were yesterday and last year and a decade ago, survives the complete replacement of your physical substance. Whatever makes you you, it is not the atoms themselves. It is the pattern, the organization, the information. And the question of whether that pattern can survive the ultimate replacement, the replacement of the entire body at once, the event we call death, is the question that sits at the heart of every chapter we have explored tonight. We have one chapter left, and in it we are going to try to bring all of this together. The science, the mythology, the philosophy, the quantum mechanics, the neurology, the ancient wisdom, and the modern uncertainty. We are going to stand at the edge of everything we know and everything we do not know. And we are going to ask the only question that matters. So here we are at the end, or perhaps at the beginning of something we cannot yet name. We have traveled a long way tonight, from the EEG of an 87-year-old man in Estonia to the gamma surges in 4 dying brains in Michigan. From the operating rooms where cardiac arrest survivors describe things they should not have been able to see to the laboratories where rats' brains flooded with dimethyltryptamine as their hearts stopped beating. From the bedsides of Alzheimer patients who woke up one last time to the Hall of Mot where Anubis weighed the heart against a feather. From the Bardos of Tibet to the Great Hall of Valhalla. From the river Styx to the bridge of Es-Sirat. From the hard problem of consciousness to the quantum vibrations inside microtubules. From a biologist who says death is an illusion to the simple, undeniable fact that every atom in your body will one day belong to something else. Now let us lay out what we actually know. We know that the brain is extraordinarily active during the process of dying. Gamma wave surges, concentrated in the regions most associated with consciousness and perception, have been documented in multiple studies. The dying brain does not shut down. It lights up. We know that some people who have been clinically dead and then resuscitated report structured, vivid experiences. Some of these experiences include verified perceptions of events that occurred while the person had no heartbeat and minimal to no measurable brain activity. The AWARE studies, the largest scientific investigations of death ever conducted, have documented these accounts under controlled conditions. We know that dimethyltryptamine is produced endogenously in the mammalian brain, that it is present at concentrations comparable to major neurotransmitters like serotonin, that its levels spike during cardiac arrest, and that exogenous DMT produces experiences structurally identical to near-death experiences. Whether the brain produces enough DMT at the moment of death to generate a full psychedelic experience in humans remains an open question. We know that terminal lucidity occurs. People with brains destroyed by decades of neurodegenerative disease can suddenly regain cognitive function shortly before death. This phenomenon has been documented by researchers, witnessed by thousands of healthcare professionals, and is now being studied prospectively with EEG monitoring by the National Institutes of Health. We know that virtually every civilization in human history has described an afterlife with strikingly consistent structural features. A journey, a guide, a moral evaluation, multiple possible destinations. These patterns appear independently across cultures that had no contact with one another. We know that consciousness remains the deepest unsolved problem in science. No theory explains how subjective experience arises from physical processes. The materialist assumption, while supported by extensive correlation, has not produced a mechanistic explanation for the existence of inner life. We know that quantum theories of consciousness, while controversial, are generating testable predictions and accumulating experimental support. Microtubules appear to play a role in consciousness beyond their structural function. Quantum effects have been demonstrated in biological systems at room temperature. And the quantum information in a system cannot, according to the laws of physics, be completely destroyed. And we know that every atom in your body was forged in a star, that those atoms will be recycled into new forms of life after your death, and that the first law of thermodynamics guarantees that the energy that is you will continue to exist in some form forever. Now, here is what we do not know. We do not know whether consciousness can exist independently of a functioning brain. We do not know whether near-death experiences represent actual perception of something beyond the physical world or sophisticated neural artifacts generated by a brain in extremis. We do not know whether the self, the specific pattern that is you, your memories, your personality, your identity, can survive in any form beyond biological death. And we do not know the fundamental nature of consciousness itself. These are not minor gaps. These are the gaps that matter most. And they are the gaps that every religion, every mythology, every philosophy, and every scientific theory we have discussed tonight is trying to fill. But there is something remarkable in the convergence across all the material we have covered. Certain themes keep recurring, regardless of the framework. A moral evaluation, the near-death life review, the Egyptian weighing of the heart, the Islamic mizan, the Buddhist karmic reckoning, the Greek judges of the underworld. In framework after framework, tradition after tradition, the moment of death involves an accounting of how you lived. A transition, not an instant termination. The brain does not flip off like a switch. Death is a process that unfolds over minutes, possibly hours. Every tradition we have examined describes stages. The dissolution of the elements in the bardo, the journey through the duat, the crossing of the river, the passage through the tunnel. Death is not a wall. It is a corridor. The dissolution of self followed by something else. Whether it is the clear light of the bardo, the tunnel of the near-death experience, or the quantum dissipation of orchestroir, something follows the end of the individual self. The ego dissolves, and then, according to nearly every account, something opens. and the importance of how you lived, karma, the weighing of the heart, the life review, the judgment of souls. Across traditions separated by thousands of miles and thousands of years, the message is the same. What you did matters, not just in this life, but at the threshold of whatever comes next. These convergences might mean that all cultures are encoding the same neurological event in different symbolic languages. The gamma surge, the DMT release, the disinhibition of the dying brain may produce a universal experience that humans have been dressing in cultural clothing for as long as we have been human. The life review is a hippocampal discharge. The tunnel is the visual cortex collapsing. The beings of light are projections of the temporal lobe. And every mythology in history is an elaborate interpretation of the same 30 seconds of brain activity. Or they might mean something more. Dr. Sam Parnia, after decades of research into the dying process, wrote that research to date has neither proved nor disproved the reality or meaning of patients' experiences and claims of awareness in relation to death. He is being careful. He is being scientific. He is saying what the data allows him to say and nothing more. And that restraint, that willingness to say we do not know, may be the most important thing anyone has said in this entire documentary. Because the question of what happens after we die is the one question that every human being will eventually answer for themselves. And no one has ever come back with a definitive report. The near-death survivors come close, but they did not complete the journey. They were pulled back. They returned to their bodies, to their lives, to a world that does not know what lies on the other side of the door they briefly opened. Science is inching closer to understanding the dying process. But consciousness remains the deepest mystery in the universe. Every religion offers certainty, but certainty is not the same as knowledge. Every philosophy offers frameworks, but frameworks are not the same as answers. And maybe that not knowing is the most important thing about being human, because it forces us to decide not what is true, we cannot know that, but what we believe, how we want to live, and what we think matters. If death is annihilation, if the materialist view is correct and there is nothing beyond the final firing of the last neuron, then this life, this moment, this breath is all there is. And it is therefore infinitely precious. Every conversation, every kindness, every sunset, every hand held in the dark is a universe of meaning in a cosmos of silence. If this is all there is, then the fact that it exists at all is the most extraordinary thing that has ever happened. And if death is a door, if consciousness survives in some form, if the soul or the quantum information or the pattern that is you continues beyond the body, then the way you lived matters in ways that extend beyond this lifetime. The life review is coming. The weighing of the heart is real. The karma accumulates. And what you carry with you into whatever comes next is not your wealth or your status or your possessions. It is the weight of your actions, the kindness you showed, the love you gave, the harm you caused, the truth you told. Either way, the conclusion is the same. This life matters. How you live it matters. What you do with your time here, however brief it is against the backdrop of eternity, matters. Whether death is a door, a wall, or a mirror, whether it leads to the field of reeds, the bardo, Valhalla, quantum dissipation, or simply nothing, the fact that your consciousness exists at all right now, hearing these words, thinking these thoughts, wondering about your own mortality, is the single most improbable and unexplained event in the known universe. Every atom in your body was forged in a dying star. Every molecule in your brain is part of a chain of chemistry that stretches back to the origin of life on this planet. Every breath you take connects you to every organism that has ever breathed. You are not separate from the universe. You are the universe temporarily organized into a person, temporarily aware of itself, temporarily asking the question. Whatever comes next, you were here, you existed, you wondered, and that, by any standard, scientific, spiritual, or mythological, is extraordinary. If you enjoyed this journey through science, history, and the mysteries of death and consciousness, please like this video and subscribe to the channel. Your support makes these detailed investigations possible. Tell me in the comments what you believe happens after we die, and what topic should we explore next. These are not just questions for scientists or philosophers. They are questions for all of us. Because the mystery of death is really the mystery of life. And every new discovery changes what we thought we knew. Thank you for listening. I will see you in the next one.